So we're going to work on this problem. A block is being pulled across a table. The forces acting on it are depicted in the free body diagram shown below. And we need to solve for the acceleration of the block. So if we begin to analyze this free body diagram, we see that we have a 25 Newton force acting to the right at a 60-degree angle above the horizontal. The normal force is 10 newtons upwards. The gravitational force is unknown and points downwards. And we have an unknown frictional force that points to the left. But the coefficient of friction is given, it is 0.2. Now to solve for the acceleration of the block, we can use Newton's second law. The net force equals the mass times the acceleration. So if we can find the mass and net force, we can solve for acceleration. This block is not accelerating vertically, it is being pulled across the table. So we need to find the net force in the x direction. Horizontally, to find the acceleration. The first step we're going to do is to split this 25 Newton force into its horizontal and vertical components. And we can do this by drawing the right triangle. Like so. I'm going to call the vertical component y, the horizontal component x. And since we have the angle, we can use sine and cosine to solve for x and y. So cosine equals the adjacent leg divided by the hypotenuse. So cos 60 degrees equals x divided by 25. And if we solve for x by multiplying the 25 to both sides, 25 cosine 60 degrees equals x. And using a calculator, x equals 12.5 newtons. Now we use sine to solve for y. Sine equals the opposite leg divided by the hypotenuse. So sine 60 degrees equals the opposite leg divided by the hypotenuse, 25. And again, we multiply the 25 to both sides. So the 25 sine 60 degrees equals y. And use a calculator again. So y is about 21.65 newtons. And since we need to solve for all the forces in the x direction to get the net force, because the net force is the sum of all the forces, we need to find the force of friction. And the equation for the kinetic frictional force equals mu k times the normal force. And the normal force is given 10 newtons, and the coefficient is given 0.2. And multiplying this together, we get the frictional force equals 2 newtons. Now, since we have solved for all the forces acting horizontally, we can solve for the net force in the x direction. And we need this to solve for the acceleration and complete our problem. So the net force in the x direction, we found earlier that the horizontal component of this applied force, this 25 Newton applied force, is 12.5 newtons. And the force of friction we just found was 2 newtons. And I'm going to define going right as the positive x direction. So the net force equals 12.5, positive 12.5 minus 2, which equals 10.5 newtons. And now, if we look back to this equation here, we have the force, so we need to find the mass to solve for acceleration. And we know that the force of gravity here equals mass times acceleration due to gravity. Force of gravity equals mg. And the acceleration due to gravity is about 10 meters per second squared on Earth. And the block is not accelerating in the y direction. So the net force in the y direction must be 0. So if we do the same thing we did for the x, and I'm summing up all the forces, if we do it for the y direction, we have the vertical component of that applied force, which is 21.65 upwards, plus the normal force, which is 10. And in the negative y direction, we have the force of gravity, which is mg, and substitute g for 10, so minus 10m. And since, again, the block is not accelerating in the y direction, all of the forces in the y direction must sum up to equal 0, because if the net force is 0, then the acceleration is 0. So this equals 0. And if we add this term to the other side and combine these two, so our mass is equal to so we take this 10 and we divide it. So what we did is we added this 21.65 plus 10 to get 31.65. Then we added this term to this side. And now we're going to divide by 10 on both sides. So dividing by 10 we get m, and dividing by 10 we get about 3.17 kilograms. And since we have solved for the mass of the block and the net force in the positive x direction, we can go back to Newton's second law and solve for acceleration. So all we have to do is substitute. So 10.5 equals 3.17a. And if we divide by 3.17 on both sides, we get that the horizontal acceleration of the block is 10.5 divided by 3.7, or about 3.31 meters per second squared. And that's our final answer.